Good evening, students. In the previous session, you have learned about how to construct two-dimensional arrays using array function and also how to check the properties of arrays. In this session, we learn about how you can create two-dimensional array using arange function, zeros function, one function, and also creating three-dimensional array. So, first of all, creating two-dimensional ndarrays using arange function. Students, you have learned in earlier session that arange function create a one-dimensional array with evenly spaced values within a specified numerical range. Similarly, you can also use arange function with reshape function to create a two-dimensional array. That means to create two-dimensional arrays using arange function, you need to do two things. Now the first one, create an array using arange function that you have learned earlier, and then reshape the created array using reshape function. Student, reshape function is new for you. Now consider what's the use of reshape function. In fact, the reshape function is used to give a new shape to a created array without changing its data. Now the syntax is array name equals to numpy dot arange start, then stop, step, dtype equals to datatype. This first syntax can be used to create an array using arange function. And the syntax B, here we use the reshape functions. So that reshape functions converts the array which was created earlier into new shape and to form two-dimensional array. Now consider the first syntax. In this syntax, a start and a step are optional, and you know very well when a start and a step value is omitted, then the numerical range is generated from 0 to a stop value with a step value 1. You are too much familiar with this syntax because arange functions are used to create one-dimensional array. Now consider the next syntax, that is reshape function. In this syntax, array name is the new array name and nd array. Here nd array means array to be reshaped, and reshape is the functions, and new shape can be specified as a row and columns, or we can say dimension, and the dimension should be compatible with the original shape. Students, the shape of originally created ndarray must be computable. That means just we consider the example. In this example, we first import numpy as np, and here a equals to np.arange of 6, and then a statement use print a. And the second statement is a1 equals to a dot reshape 3, 2. Here the first statement, that is a equals to np dot arange of 6, creates one-dimensional array with 6 elements like this one. That is, whenever you print this array, print a, then output will be like 0, 1, 2, 3, 4, 5. In these arange functions, we omit a start and a step value, so that the array is created by default from 0 to the stop value by increasing step 1. So that is why the array value is created like 0, 1, 2, 3, 4 and 5. Now in the second statement, that is a1 equals to a dot reshape 3, 2, creates a new reshaped two-dimensional array with 3 rows and 2 columns. So here A1 is the new array name, and A is the previously created array name, that is A. Here array A should be capital, and whenever print A1, then the previously created array, that is 0, 1, 2, 3, 4, 5, is now converted into two-dimensional array, and that is 3 rows, 0, 1, first row, second row 2, 3, and third row 4, 5. So 3 rows and 2 columns. So whenever we create two-dimensional array using arange functions, we must have to use reshape functions, and while we using reshape functions, you must remind the following points: that the number of elements in the created array must be the same as that of a new two-dimensional array being created through a reshape function. Now move to the next. Now creating two-dimensional array using zeros function. You have already utilized zeros function for creating one-dimensional array. Similarly, zeros functions can also be used for creating two-dimensional array. Now let us see. So once again, we remind you, zeros functions means this function is used to create two-dimensional array of a given shape and data type filled with all zeros. That means this function creates an array with a specified size and type but filled with zeros. Now consider the syntax. In fact, today we also use import functions in different ways. That means you can import numpy by using 3 different ways. Now consider the first syntax, import numpy. you can import very simply import numpy or import numpy as np or from numpy import asterisk. Now, what's the basic difference between these three? The first one, when you import numpy as import numpy only, then you use in syntax, for example, array name equals to numpy dot zeros is the function, then shape, and optionally data type, d type equals to data type. So if you call numpy, simply import numpy, then in the syntax, whenever you used the zeros functions along with numpy, numpy. Now, when you import like this, and this one is very commonly used, import numpy as np. Here numpy module assigned as np, and so that the syntax is array name equals to np. That's the difference. In previous we are using numpy because we call numpy as numpy only. Here we import numpy as np so that instead of numpy we use np. So np dot zeros, then shape, then d type equals to data type. Now the third one is also from numpy import asterisk. It means you import the numpy modules with all its functions. In this case, the syntax will be array name equals to zeros, then shape, d type equals to data type. That means here np or numpy need not necessary to write the syntax because all these modules are included in this syntax. So you can use any one of these three syntax for creating two-dimensional arrays using 0. Now consider the example. While import numpy, then a equals to numpy dot zeros 3, 2, d type equals to int. It means here a is the name of the array and we import simply numpy so that the function used as numpy dot zeros, and this is the shape. So here we use 3, 2. 3 is the row and 2 is columns, and d type is int. That means the array is created using 3 rows and 2 columns having the type integer and filled with zeros. That means the data zeros functions filled the data elements as 0 to all the elements. The same syntax can be used while you import numpy as np. Then the statement is a is equal to np dot zeros, then 3, 2, then d type equals to int. Similarly, from numpy import asterisk, then the statement is a equals to zeros, then 3, 2, d type int. And while this statement, any one of this syntax will executed, then what's the result? The array is created having two-dimensional with 3 rows and 2 columns and data type int, so that the output will be, when you print the array, then output is 0, 0, 0, 0, 0, 0. This one is the first rows, then second rows and third rows. And while you assess this one, the first element will be the a of 0, 0, etc. So we will discuss in later how to assess one-dimensional arrays element or two-dimensional arrays element. Now move to the next. Now creating two-dimensional ndarrays using ones function. As you know, ones function and zeros functions basically are the same, but zeros functions filled the data element with zeros and ones function filled the data with ones. So same syntax can be used for creating two-dimensional arrays using ones functions. Look, here we utilize the three syntax same as previously, created with zeros function, import numpy as np, and from numpy import functions. Now consider the example. In this example, a equals to numpy dot ones 3, 2, d type equals to float. It means when this statement is executed, then it creates the array having name A with 3 rows and 2 columns, but the data type is float and filled with ones. So while you are using any one of these threes, whether you are using the first syntax or second syntax or third syntax, then the output will be the same. So while you execute it, then output will be 1 point, 1 point in the first row. Second row, again 1 point, 1 point. Here 1 point means the floating data. Again 1 point, 1 point. So if you define the data type, what you see? You see the stored data in a particular type. While you specify d type equals to int, then what's the result? The result will be 1, 1, 1, 1, 1, 1. So students, right now you have learned how to create two-dimensional arrays using array function, arange functions along with reshape function, then the zeros function and ones functions. Now we just consider how to create three-dimensional array. In fact, three-dimensional array is not in your syllabus, but we just see how to create three-dimensional array. So simply, the two-dimensional array means array of arrays. Similarly, three-dimensional arrays means array of arrays of arrays. And the rest thing is the same as you utilize in two-dimensional array. Just consider the example. Here A is the array name equals to numpy dot array. We use array function. Then you see the 3 brackets nested 2, 5, 8. This one is the list. And 6, 4, 3 is another list. So these two lists are nested. That means array of arrays, two-dimensional. While you are using 2, 5, 8 only, then this one is considered as one-dimensional. And while you utilize the two lists nested with each other, that is 2, 5, 8 and 6, 4, 3, then this is two-dimensional. And now the again nested two list. So that means array of arrays and of arrays, and that is seen to be three-dimensional arrays. So In such a way, you create three-dimensional array. Likewise, fourth dimensional array means multi-dimensional array means two-dimensional, three-dimensional, four-dimensional, etc. And I think you have learned to create one-dimensional array, two-dimensional array, and a little bit three-dimensional array. Now in the next session we will discuss about the assessing or array manipulations. So thank you and have a nice day.